Good morning, students. We'll start. Any doubts in the marks? Introduction of marks. Whatever the things we studied in the yesterday's class. Any doubts in the last class? I think this one overnight yesterday. Quad multiplexer used to select the 4-bit data. Explanation of this override. Is this circuit over yesterday? This one. Okay. So this is the circuit to select one of the 4-bit data. Correct, right? This is the one of the application of the multiplexer. Now look at this. So look at this circuit. So what we did with this circuit? See, when a equal to 0, when a equal to 0, x0 will be reflected at z0, x1 will be reflected at z1, x2 will be reflected at z2, x3 will be reflected at z3. Similarly, when a equal to 1, y0, y1, y2, y3 will be reflected at z3. Means at a time I will be having 4 bit of output. At a time I will be having 4 bit of 4-bit of output, either x0, x1, x2, x3 or y0, y1, y2, y3. Now what we are going to do here is, see, these are the input signals, correct, right? So all these input signals are going to perform a common function. See here, so the logic signal that perform a common function may be grouped together to form a bus. So x0, x1, x2, x3, all these 4 bits are going to select it together, which means that these 4 logic signals are going to perform a common function. Similarly, y0, y1, y2, y3 going to perform a common function. So when the condition is like that, what we are going to do here means, whatever the signals are there doing the common function, we are going to replace those signals by a bus, single bus. Here. So, so the bus, instead of drawing the individual 4 lines, so when you compare with this, here we have x1, x2, x0, x1, x2, x3. Similarly, y0, y1, y2, y3. So all these two together going to do the same function. Instead of writing this individual signal, what we are going to do here is, we are going to indicate in terms of bus. See, instead of drawing the individual, when it makes up with the bus, we are going to make that with the bus. Ma'am, how to identify whether it is a bus or signals. See how we have written the signal. Signals are written with the thin line. Signals are written with the thin line. So the bus is represented by the thick line or heavy line. The bus will be represented by the heavy line or thick line. Okay, so when we are going to rewrite this quad 2 to 1 mux multiplexer, we are going to replace this by a mux. Sorry, that with the bus. So when we are going to rewrite that circuit with the bus, it looks like this. It looks like this. So here we have x and y are the input signals, z is the output signal, similar to the previous circuit. Even a is the control line. So same way here also. When a equal to 0, when a equal to 0, x will be selected. When a equal to 0, x will be selected and it will be reflected at z. So what is the value of capital X? What is there under this x? Under that x I have x0, x1, x2 and x3. Okay, when a equal to 0, this will be selected and it will be reflected at z. It will be reflected at z. So what is there under capital X? X0, x1, x2, x3. That is the 4-bit data. When a equal to 1, when a equal to 1, y will be selected and it will be reflected at z. So what is there under y? Under y I have y0, y1, y2, y3, y1, y2, y3. So this will be there under y. So when a equal to 0, this will be selected and it will be reflected at the output side. So one more thing you can see here, one more thing you can see here, along with the line, along with the bus line or along with this thick line, I have a diagonal slash here. I have a diagonal slash with one number. Hope you can see. So this thick line represents the bus. So here I have a diagonal slash line with the number along with the bus. So this represents the number of bit. It specifies the number of bits available along this particular bus. Number of bits available along with this particular bus, which means that under the bus X we have 4 bit, that is x0, x1, x2, x3. Again under the bus Y we have 4 bits, y0 to y3. Similarly under Z I will be having the 4-bit output. So wherever the logic signals are going to perform the same function, that can be replaced by the bus. Is this clear? Guys, are you clear with this? Where we will be using the bus? Any doubts in this? Any doubts in bus? Where we will be using the bus? What about others? Others are having breakfast? Are you guys having breakfast? So next we have the multiplexer with the extra input called enable. See here, so here you can see the 4:1 marks. This is, you can see 4 4 is to 1 marks, correct, right? So one output I have, four inputs we have, two selections lines we have. Can you see anything extra here? Is there anything extra here? So you can see one extra input called enable, correct, right? So before we do this, before explaining this enable, so whatever the multiplexer we studied till now, whatever the multiplexer, that is 2 to 1, 4 to 1, 8 to 1, whatever it is generally, whatever the multiplexer we have studied, is it going to invert is data input, or whatever the thing we are going giving, it will be reflected at the output side? The question is, what multiplexer we studied from yesterday, is the data inputs are inverted, or it will be same as what we are given? Same as given, correct, right? Whatever the thing I will be giving, it will be reflected as it is at the input side. I'm not speaking of the output, just what I will be taking from the switch, same thing will be pushed on to the multiplexer. If I want to invert my input, data input, what I want to do? If I want to invert my data input, what you want me to do? Sometimes some multiplexer will invert the input. Any idea? Use the NOT gate, add the inverter. Okay, so if you want to invert at the input side, you want to see, instead of inverting at the input, can we invert at the output side? Because if it is at the input side, for every input switch you need to add, because you may having 4 input data input, 8 data input, or 16 data input. Instead of adding the inverters for 8 times, 4 times, 16 times, can we invert that at the output side? So when you invert at the output side, you are going to replace only, or you are going to replace only one gate, correct, right? See here we have an example for 8 is to 1 mark. Suppose I want to invert my data. See, when a b c equal to 0 0, this will be selected and this will be reflected here. Now I don't want data to be as it is, I want my input to be inverted. So if I want to invert, what I want to do, see, 1 2 3 4 5 6 7 8, instead of, either I need to replace this 8 AND gate with the NAND gate, or I need, you want me to add the inverter in the beginning of I naught. Here only I need to add the inverter. So instead of adding 8 inverters, or instead of replacing this AND gate with the NAND gate, what can I do? I can replace this OR gate with the NOR gate. So when you want to invert, when you want to invert the data input, it's better to replace the gate at the output side. Okay. So wherever it is necessary, it's not all the time. Wherever it is necessary, in that cases, when you want to invert the data input, replace the output gate. Next we have, okay, next we'll come back to this. So you people told, so here we have 4 is to 1 marks, 4 is to 1 marks. So you people only tell, we can see extra here. So what is the extra thing here? Extra thing is here, e. Extra thing is here, here E. So whatever the multiplexer we have studied till yesterday, so in that we will be having data inputs, one output. Depending on this 2 to the power of n data input means we will be having n number of selection lines or control lines. So this is the 4 to 1 mark. So we have 4 data inputs, 1 output and 2 control lines. So along with this, so you take any type of multiplexer. Any type of multiplexer means it can be 2 to 1, or it can be 4 to 1, or it can be 8 to 1, or it can be 16 to 1. You take any type of multiplexer, so it will be having an additional input. It will be having an additional input called the enable input. So it called as a enabled input. So this is another type of multiplexer. So the multiplexer which is having the additional input called enabled, this multiplexer is called as a another, means it is a another type of multiplexer. If we have the multiplexer, then how it will work on? So this is connected to the, means we will treat this enable as a fifth input. It will be treated as a fifth input. So now, if e equal to 0, if e equal to 0, if e equal to 0, z will be 0. If e equal to 0, z will be 0 independent of the gate input. Okay, when e equal to 0, z will be 0 independent of the gate input. So okay, whenever ABC is selected, it will be act. When e equal to 1, when e equal to 1, it will act as normal multiplexer. It will act as normal multiplexer. So output look at the output side, look at the output side. Is it output is inverted? Is the output is inverted? No, correct, right? So one thing you need to remember, when enable is 0, we will call it as a active low. We will call it as a active low. When enable, make a note, when enable equal to 0, we will say the multiplexer is active low. Okay, active low enable. When e equal to 0, the z will be 0 independent of the selection lines and depending on the I. When e equal to 1, when e equal to 1, we will say it is a active I enable. When e equal to 1, we will say it's a active I enable. So when e equal to 1, it works as a normal multiplexer. So depending on the selection, it will select I naught at Z. Depending on 0 1, I1 will be selected and reflected at the Z. So similarly, look at the second one. Look at the second one. Here also same thing. When E equal to 0, Z will be depending. Suppose when E equal to 1, when E equal to 1, it will act as a normal multiplexer only depending on the control line. But what about at the output side? Just look at Z. Look at Z. Look at Z. What we have at Z? Second one. So we have the inverter. So at the output side, we have the inverter. We have the inverter. So what will happen at the output side? The whatever the data input you are going to select, that will be inverted at the output side. Suppose if I not equal to 0, suppose if I not equal to 0, if selection lines are 0 0, selection lines are 0 0, I not will be reflected at the output, correct, right? So what will be the value of z? So here I not equal to 0, because of in this inverter, here I not will become 1. This is equal to your z. This is equal to your z. Suppose if I3 equal to 1, I3 equal to 1, if selection lines are 1, 1, I3 will be selected and it will be reflected at z. So what will be the value of z? 1 will become 0 because of this inverter. Clear? Guys, is this clear? So next look at this next to two diagram. Next to two diagram. This is also similar to this only. So we have here also enable. Can you tell the difference? If you understood the figure A and B, you can tell C and D. What is there in C? Input E is inverted. Yes, input E is inverted. Okay, enable is inverted. When the enable is inverted, when it will act as a multiplexer, when it will be active. If you give what value for enable, it will be active. Very good. So when E equal to 0, when E equal to 0, it will be active. So that's the reason we will call it as an active low enable input. Active low enable input. So your enable equal to 1 means it will act. So this will call it as a active I. Okay, active I enable. This is also active I enable, but output is inverted. Output is inverted. Thus figure C, E is inverted. That's the reason when E equal to low, when E equal to low, low is nothing but it's 0. When E equal to 0, the multiplexer will work out. Correct, right? That's the reason we will call it is a active low enable. When enable key equal to low or when enable input is 0, the multiplexer will be active. So we call it as a active low enable multiplexer. C is clear. Figure C is clear. Any doubts in C? Okay. Now look at D and tell me. Look at the diagram at D and tell me what it is there. When it will be active and what will be the output. So in C, when 0, when enable is 0, it will be active, and depending on the selection lines, it will select the data input and same thing will be reflected output. What about D? What about D? Look at the diagram and give me the answer. Active at 0 and output is inverted. Very good, Ankita. What about others? What about others? Only Ankita answered. Just look at the diagram. Just look at the diagram. So at the enable input side, it's inverted. It is inverted. Enable input is inverted in the sense it will be active when E equal to 0. Okay. It will be active when E equal to 0. So what we can say that? We can say that active low enabled multiplexer. Look at the output side. Look at the output side. It is inverted. It is inverted. Means whatever the data input will be selected, that will be inverted at the output side. Okay, because this you should know when we will be doing PLA and PAL. even demultiplexer also. When it will be if inputs are inverted, what will happen? If output is inverted, what will happen? Is this clear? Any doubts in this? When we will replace multiplexer with the bus multiplexer, in the sense the logic signal will be replaced with bus, and another type of the multiplexer with enabled input, additional input called enabled input. Guys, any doubts in this? No doubts in theory, then we'll move to the problems. Okay, so there are problems. Take down this question. Take down the question fast. Copy this question. If you have any doubts in the theory of multiplexer, you can clarify. Copy the question. Show, show how, show how two 2 to 1 multiplexer, two 2 to 1 multiplexers in bracket with no added gates. With no added gates. Means we are not going to add any extra gates here. Multiplexer could be connected, could be connected to form a 3 to 1 max. To form a 3 to 1 max. Full stop. Input selection should be as follows. Input selection should be as follows. If AB equal to 0, 0, if AB equal to 0, 0, select I naught. Means when the selection lines are 0, 0, we need to select I naught. Second one, if AB equal to 0, 1, if AB equal to 0, 1, select I1. Select I1. If A equal to 1, if A equal to 1, B's don't care. Means hyphen means B's don't care. Select I2. Select I2. Once you copy, drop the message in the chat box. Finished? So next, others. Answer at next 1 to 5. Answer at means 1 to 5. 6 to 10. 11 to 15. 16 to 20. 21 to 25. Copy the questions. What is there in the question? Read out the question. So they asked us to construct or to show two 2 to 1 multiplexer. Two, they only told we have to use two 2 to 1 multiplexer. We are not going to add any added gates. Okay, could be connected to form a 3 to 1 marks. So till now we studied only 2 to 1 marks, 4 to 1 marks, 8 to 1 marks, 16 to 1 marks, 32 to 1 marks, like that. Correct, right? But they are asking us to construct the 3 to 1 marks using 2, 2 to 1 multiplexer. So they are only given the condition how we should select the inputs. If A equal to B equal to 0, however, so we are using two multiplexer, 2 to 1 multiplexer. So in the both we will be having one for one control, one multiplexer, another control input for the another multiplexer. Total we have two control lines. So that is AB. That is AB. So when A, B are 0, when A, B are 0, I need to select I naught. Input I naught. When A, B equal to 0, 1, I need to select I1. Okay. When A equal to 1, but B's don't care. B's don't care means it can be 0 or it can be 1. I need to select I2. So this is the condition. To satisfy this condition, I need to construct the multiplexer. Okay. Let's start constructing. So they only told we need to use 2 to 1 marks. Guys, don't forget to write inside what you are going to use, because next we will be studying decoder, encoder and all. So all looks like same. Okay, so you need to represent inside 2 to 1 marks we are going to use. So one more we need to use. 2 I need to use. Okay, so this is also 2 to 1 marks. This is also 2 to 1 marks. So for this I will be having one output and two input, one selection line, and here also I will be having two inputs, one selection line and one output. So this is my output set. From this I need to construct, 3 to 1 multiplexer. Okay, 3 to 1 multiplexer. Let me give input names. We have only three inputs: I naught, I2, sorry, because 3 to 1 marks, right? So we should have 3. but we are here we have four, so we'll see what to do with one more. So I naught, I1, I2. Now we have control lines here. So where to take A, where to take B, we'll see it. So what is there in the question? If AB, if AB equal to 0, 0, what I should select? I should select I naught. When it is 0, 1, I need to select I1. When it is 1, don't care, I need to select I2. Correct, right? So this is multiplexer 1, this is multiplexer 2. Let me write this. Okay. So what should be the selection line of multiplexer 1? Here it should be A or it should be B. What should be the selection line of first multiplexer? It should be A or B. Should it be A or B? Guys, give little work to your brain. Simply don't sit. So Aditya Raj is saying B. What about others? Okay. Aditya, I'll come back to your answer. Maximum of you people giving A. Okay. Let me give A. Let me give A. So if this is A, this is B. Okay. If A equal to 0, if A equal to 0 and B equal to 0, I need to select I naught. Correct, right? I need to select I naught. So because of this is 3 to 1 marks, what I will do here, output of the multiplexer will be connected to one input of the second multiplexer. Okay, when both are 0, you selected I naught. I'll give all the option. Next, A equal to 1, sorry, A equal to 0, B equal to 1. A equal to 0, B equal to 1. When A equal to 0, again what it will be selecting? See, first condition is satisfied. First condition is satisfied, correct, right? When A equal to 0, again what it is going to select? Those who answered A, please answer now. Are you getting my point? See, when A equal to 0, it is going to select I naught. So first condition is satisfied. When you are going to select next, that is A equal to 0, actually A equal to 0, B equal to 1, I need to select I1. But still again it is selecting, again it's selecting, guys answer. For the second condition also, for the second condition when A equal to 0, B equal to 1, what we need to select? It should select I1, correct, right? But what it is selecting? We should select I1. But when A equal to 0, what it will be selected from the first multiplexer? It is going to select I naught. Means there is a mistake there. So what we need to change now? What we need to change? Means first condition is accepted. Second condition is not accepting. Just interchange the selection lines and see. Just interchange the selection lines and see. We'll interchange the selection lines and we'll see whether it will work properly. Okay. I'll change this to B and this to A. Now check. A equal to 0, B equal to 0. A equal to 0, b equal to 0. First condition, correct, right? See, when b equal to 0, when b equal to 0, I naught will be selected. Change the colors. When b equal to 0, I naught will be selected. I naught will be selected. So at z naught, I will be having I naught. At z means, see, when b equal to 0, from this multiplexer I naught will be selected. So what is the input of this multiplexer? This is I naught. This is I naught. Okay. When a equal to 0, first input will be selected. When a equal to 0, first input will be selected. So at z naught, I am having I naught. So when a equal to 0, b equal to 0, I need to select I naught. So I have I naught. So this is accepted. First condition is accepted. So all the three condition I will represent it in the different colors. When b equal to, second condition, again second condition, a equal to 0, b equal to 1. So let's check from the first multiplexer. When b equal to 1, which data input will be selected? When b equal to 1, which data input will be selected? The selected input is I1. The selected input is I1. So this will be selected, and in this I will be having I1. When b equal to 1, this will be selected, and at output I will be having I1. Correct, right? So here first input of the second max will be I1. So what I have here, what is the selection line of A? Selection line of A is 0. So it is going to select I1. So it is going to select the first input, and this will be reflected at the output side. That is I1. Is the second condition is satisfied? When A equal to 0 and B equal to 1, at the output side we have I1. Is the second condition satisfied? Yes. So second condition also satisfied. Now, now last condition. A should be 1. A should be 1. A should be 1. We don't know the value of B. B means don't care. It can be this or this. Don't know. Okay. When A equal to 1, from this multiplexer, which input symbol will be selected? This I not I1 or I2? When A equal to 1, which will be selected? It will be selected I2. Very good. When A equal to 1, I2 will be selected. I2 will be selected. So when A equal to 1, B's don't care. The selected input is I2. So all the three conditions are satisfied. So this is the structure of multiplexer. From using 2 to 1 multiplexer, we constructed 3 to 1 multiplexer. Yes, is it clear or any doubts? Any doubts? Copy it. Copy it. Write on fast. Copy it. But copy from here. So you better you write down the condition also. Once you copy this, copy the select second question also. Show how 2 4 to 1 marks and 1 2 to 1 multiplex. After copying the answer for the first one, just copy the second question. Maybe what we want me to explain? Problem? Full problem want me to explain? See what is there in the question. They are asking us to construct 3 to 1 marks from 2 to 1 multiplexer. Correct, right? So 2 to 2 1 multiplexer means we will be having two control lines, one for each. One for each. So this is the representation of 2 to 1 marks and 2 to 1 marks. But they are asked us to construct 3 to 1 marks. So but we have 4 inputs. So what you are going to do, first output will be connected to the first input of the second mark. First, if you take A and B here, first condition will be satisfied, second condition won't satisfy. So what we did is just we interchange the selection lines. So we have taken B here and we have taken A here. So when B equal to 0, here I naught will be selected. B equal to 0 means first input will be selected from 2 to 1 mark. So this I naught will be reflected at output of the first marks. Even this output is connected to first input of the second max. So when b equal to 0, I naught is selected. What about I when a equal to 0? When a equal to 0, first input will be selected and it will be reflected at the z. So what is there at the first input? I have I naught. So according to this condition, we got I naught here. So that is satisfied. Next condition is a equal to 0, b equal to 1. Again a equal to 0 here, b equal to 1. So when b equal to 1, second input will be selected. So second input is I1. So at the output side I1 will be reflected and here I will be having I1. So when a equal to 0, I am going to select the first input. So what is there in the first input? I1. So at Z, now at Z output side I1 will be reflected. So second condition is satisfied. Third condition, when a equal to 1, we don't know about the b, don't worry about b. So when a equal to 1, second input will be selected, that is your I2. So I2 will be reflected at output. So third condition is satisfied. Is it clear? Guys, have you copied the second one? Second question, have you copied? Copied the second question. Reply fast. Okay. So what is there in the second question? So show how 4 to 1 marks, 2 4 to 1 marks. See number also they only mention 2 4 to 1 marks and 2 2 to 1 multiplexer could be connected to form an 8 is to 1 marks with 3 control inputs. With 3 control inputs. They told us to take 2 4 is to 1 marks. So this is 4 is to 1 marks. So how much we need to take? We need to take 2. 4 is to 1 marks. So how many inputs will be there? 4 inputs. 4 inputs. Each takes 4 inputs. So label with I naught, I1, I2, I3, so your I4, I5, I6, I7. Okay. Then 2 to 1 multiplexer. 2 to 1 multiplexer. 2 to 1 mux. For this, I will be having two inputs and one output. Totally, how many selections lines we have? So they mentioned in the question how many control lines? How many control lines? Three control lines. Correct, right? So these three control lines, where you guys are going to connect. For 2 to 1 mux, how many lines are required? For 2 to 1 mux, how many control lines are required? One. Okay, I'll put one for this mux. So what should I give name? What should I label for that? Give anyone name for that control line. Is that usually we will take for output, right? People are saying A. So how many more remaining? How many more remaining? Two. Where you will connect that? Where you will connect those two? Where you will connect those two control lines? 4 to 1 mux. For both same or for both different? For both the 4 to 1 mux, are you going to use the same control lines? Because we have totally 3. Out of 3, we have used 1 for 2 to 1 mux. We are left out with 2 more. Different one. So means totally how many you want? If you use the different one. For this two, totally how many you want? So if you use the different control lines, totally how many control lines are required for both 4 to 1 mux? 4. But how many we have? How many we have? 2. So what you are going to do? We required 4, but we have only 2. What you are going to do? Same control line. So for both 4 to 1 mux, you are going to use the same control lines. For these 4 to 1 mux, you will be using the same control line. B, C, B, C. So here I have one output. Here I have one output. So output of these mux should be connected to where? So I need to form 8 is to 1 mux. I need to form 8 is to 1 mux. See, I got 8 input, I got 1 output. I got 8 input and I got 1 output. But in between connections are missed. Output of the 4 is to 1 mux should be connected to where? So Purva saying input of 2 to 1 mux. Exactly. So this should be connected here. This should be connected here. Is it looking like 8 is to 1 mux now? Is this looking like 8 is to 1 mux now? Yes or no? Copy it. Copy this. See? two 4 to 1 marks. We have used two 4 to 1 marks and one 2 to 1 marks. One 2 to 1 marks. So now we need to form 8 is to 1 marks. So 8 input, 1 output with 3 control inputs. So for this we require two selection lines. For this we required one. But for both the multiplexer you have to use same selection lines. Copy fast. ಯಾಕೆ ಸರ್ ಬುಕ್ಕಾ ಎಚ್ ಓ ಡಿ ಹತ್ರ ಹೋಗ್ತಿದ್ದೀರಾ ಮಾಮೂಲಿ ಅಸೈನ್ಮೆಂಟ್ ಬುಕ್ಗಳಿದೆ ಅಷ್ಟೇ ಇಟ್ಸ್ ಫಿನಿಶ್ಡ್ finished. Now can't we connect the data input lines together with both nodes? Means what, Lavanya? You can unmute and ask. Both the marks means like from 4 to 1 marks. Those those B and C lines both together you can connect, but how you'll connect? It's very difficult to write. No, that's the reason we connect it separately. Together, usually it's like ICs, right? IC will be having separate switches to uh, control lines separate. You will be having data inputs lines, control lines you will be having. So you have to make a connection, right? I think you are asking like this, right? Like this, isn't it? Like this, are you telling? Actually, you cannot connect. I think you are asking like this. Like this also you cannot connect. Okay. Take the next question. Show how 4 2 to 1 and 1 4 to 1 multiplexer could be connected to form an 8 to 1 bus with three control inputs. With three control inputs. The question: show how 4 2 to 1 and 1 4 to 1 multiplexer could be connected to form an 8 is to 1 mux, an 8 to 1 mux with three control inputs. With three control inputs. Write down fast. Class 11. The next, finished copying. I think this problem you can solve. Try it. You can solve this. Try it. Can you do that? First, let me ask. Can you do that? Excuse. Guys, can you solve the problem? Solve.
ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಓದ್ತಾ ಇದ್ದೀರಾ? ಏನಿದೆ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀರಾ? ಯಾವ್ದು ಗೂಗಲ್ ಮೀಟಾ? ಏನು ಕಾಪಿ ಪೇಸ್ಟ್ ಎಲ್ಲ ಮಾಡಿದ್ದೀರಾ?
Problem.
ಹೌ 4 2 ಲಾಸ್ಟ್ ಗೊತ್ತಿದೆ ಇಡೀನ
Guys, finished? Anybody got the answer? Chakravardhan, you there? Chakravardhan? Chakravardhan, you there? Can you send you an answer, Chakravardhan? Take a pic and WhatsApp me. Chakravardhan, have you sent? Someone sent. I don't know who is that. 449 last number. Chakravardhan, please reply fast. Or who sent that? You can reply. At least you can send your name. It's Naveen. Chakravardhan, how long you want? Ah, Naveen, it's correct. Pa. Pranav, Pranav, Tushar. How many times I told you people? Just type your name also. Ah, Kavya, correct. Ah, Pranav, send the answer fast. Ah, Kavya, for 4 to 1 marks, one more selection line. You no, 4 to 1 marks. How many control lines are required? Kavya, 4 to 1 marks. How many control lines are required? Two control lines are required, right? Correct it. Correct it. Pranav and Chakravardhan, for both of you today absent. Yesterday people didn't get absent message, so you people are happy, right? Okay, let me do this today. Yes, 481, it's correct. Who is this? 751. Oh, Pranav, very good. Your answer is full correct. They are dreaming when I was explaining. If I put absent, then tomorrow you people will sit correctly in the class. Okay, okay, guys. I'll tell the answer. Look at the answer. Okay. So how many 2 to 1 marks they told? They told 4 2 to 1 marks. They told 4 2 to 1 marks. So take 4 2 to 1 marks. 2 to 1. You write properly, okay? 2 to 1. 2 to 1. So many inputs will be there. Two inputs, two inputs, two inputs, two inputs. Label I not I1. Just I am writing the number. Insert I, prefix I. 2, 3, 4, 5, 6, 7. So there will be one selection line. There will be one control line. So they asked us three control lines. Let me take ABC. Three control lines are there. So two are required for 4 to 1 mark. So one is left out. That is A. A will be the common control line for all the 4 2 to 1 marks. Kavya, change now. So we have four outputs. We have four outputs, one from each 2 to 1 marks. So this will be the input for 1, 4 to 1 marks. 4 to 1 marks. So two selection lines, that is B and C, and one output, that is your set. One output, that is your set. Is this clear now? So those who are done and not sent the answer, just verify the answer. Any doubts? Any doubts? Take on the next one. This we'll do tomorrow. This problem will do tomorrow. Take down next. Take down this. Show how 4 to 1 multiplexer. Show how 4 to 1 multiplexer can be obtained using only 2 to 1 multiplexer. Using only 2 to 1 multiplexer. Construct. Show how 4 to 1 multiplexer can be obtained using 2 to 1 multiplexer. So you are going to use only 2 to 1 marks. So how many you want you to say? So totally how many 2 to 1 marks are required? Totally how many 2 to 1 marks are required? Only 2, Lavanya. 4 to 1 marks. So you are going to make 4 to 1 marks using 2 to 1 marks. Totally how many marks are required? 2 to 1 marks. Naveen, is it 4? Then send the answer fast. If people are saying 2 are enough, okay, send the answer fast. Now Kavya said it's 3. So which one, Kavya? Should I accept 2 or should I accept 3? What about others? Anybody other than Kavya? Is 2 is correct, 3 is correct. Okay, people are saying 3. Yes, 3 is correct. It's not 2, 3 is required. Finish it. One is absent. 26 to 30. Answer it means 26 to 30. 31 to 35. 36 to 40. 40. 41 to 45. 46 to 50. 50. 51 to 55. 56 to 60. 56 to 60. 57. Wait. Wait. Guys, wait. 61. 63. 63 to 70. 63, 64 absent. 364. 71 to 75. Sorry, Harish, I can't go back. 75, 76. 71, 73. 75. 76 to 80. Maithili, you there? 81 to 89. 84 is not there. Okay, guys, got the answer. What you were doing Hemant Reddy when I called your name? It's when your series was there. No, I'm not changing the attendance right now. In front of you people only, I will save and close. See, if it is 1 day, if it is 2 day, we can tolerate. If same thing from past 2 months, got the answer? Guys, got the answer? So this is the answer. Verify it. So 4 to 1 marks using 2 to 1 marks. So 1, 2, 3, 4. 4 inputs, 1 output. Okay. So take one over problem. Take down this. Construct. Construct. It is to 1 marks. Construct. 8 is to 1 multiplexer using 2 to 1 multiplexer. Construct 8 is to 1 multiplexer using 2 is to 1 multiplexer. Construct 8 is to 1 multiplexer using 2 is to 1 multiplexer. Copied. Copied. Take the run mark. Take the run mark. I can ask answer from anyone. Okay. It is not there. Another kind of problems are there. Okay, only do this one. Remaining will do it in the next class. Guys, any doubts? Just they will give the question like this, but you should know where we need to take the selection lines, which are the inputs, where to keep all those things. It's very easy problems constructing the multiplexer. Okay guys, thank you. We'll see it in the next class. Please solve that and come.